Hi Pre-Calc. Here is your lesson for compound interest. So you should have watched the lesson that's about percent growth and percent decay before watching this, because we chat a little bit about some formulas and we create some formulas together. So knowing that, Avery deposits $200 in a bank that pays 8% simple annual interest. How much total money will Avery have at the end of 1 year? So I'm starting with $200 and I'm increasing by 8% for 1 year. So going by my y equals a times 1 plus or minus my percent raised to the x power, I can say that y is equal, my starting value is 200, 1 plus 0.08, and for 1 year. So y is equal to 200, 1.08 raised to the first power. At the end of 1 year, Avery will have $216. So moving forward, at the end of the year, Avery decides to continue saving money and she redeposits all of the money. So the initial $200 plus all of the interest for another year. How much total money will Avery have at the end of the second year? So we could say y is equal to 216, 1 plus 0.08 raised to the first power. Or we could say that we're starting with our initial $200 and I have my 1.08 raised to the second power because I'm doing the same thing for 2 years. So at the end of that 2 years, Avery will have $233.28. So I could have done this here and it would have yielded the same answer for me. So what have we been doing? Our value in the future is equal to the starting value times 1 plus our percent raised to the amount of time. So this is the equation that we've been using up above. So what we've been doing is we've been compounding our interest once per year. So when I say compounding, I mean we've been adding on our interest to our initial investment one time per year. But what if we were to compound semi-annually? This would mean that we would add our interest on semi-annually. This is twice per year. So we would add on our interest twice per year instead of just once at the end of the year. So what does this kind of look like? We're adding our interest twice, but throughout the course of the year, so here, let's go back and read this problem. Jake invests $1,000 in a bank account that earns 10% interest semi-annually. How much money will Jake have at the end of 1 year? So my 10% interest rate is happening over the course of 1 year, but I'm getting to this 10% by finding 5% at 2 times. So there's that semi-annually, 2 times throughout the course of the year. So overall, for the entire year, my percentage is 10%, but I'm splitting it up and I'm adding it on twice a year. So let's just take a look at what that looks like. So in January, I'm starting with $1,000. Over the course of the first 6 months of the year, I'm figuring out what 5% of 1,000 is, and I'm adding that into my account. So I end up with $1,050 in June. Then another 6 months goes by, and I'm adding on the last 5% of my 10% interest rate. And if we look, 10% of 1,050 is $52.50. So at the end of the year, I don't have $1,100 if I were to just compound once at the end of the year. I have a little bit more money in December. So I'm adding on that 5% twice. So that's compounded semi-annually. So we can sort of think about what we just did. It looks like we took, in talking about this formula here, this A equals P, let's write that down here. A equals P, 1 plus my percent raised to the n power. So what I was really just doing is A is equal to 1,000, 1 plus my percent. I sort of chopped it up twice over the course of the year, and I did that 2 times. So the number of times that I am compounding my interest, and since we're just talking about 1 year, I did that 2 times. So I want to figure out that percentage twice. So looking here, if I were to compound something quarterly, I would do the same thing. I would start with this $3,000, and a quarter of the way through the year, this would get me to half the year, 3/4 of the year, and lastly, a full year. I would be adding on 2% each time. To eventually get me to my total value in the end. So I'm taking my $3,000 and I'm doing 1 plus 0.08 divided by 4 because I'm compounding quarterly. And I'm doing that 4 times throughout the course of 1 year. So this will end up yielding $3,247.30, which is more money than if I were to just compound once a year at my 8% interest rate. If that were the case, I would be figuring out what is 8% of $3,000, and I would add that value 1 time per year. So we can see, based on sort of our trend up here, the more times that we compound our interest, although it's still 8% for the total of the year, the more times that we compound our interest, the more money we're ending up with at the end of the year, because 2% of 3,000 is less than 2% of this value right here that will happen after a quarter of the way through the year. So here's the formula that we have sort of been coming up with. My compound interest formula. So A is the future value of my investment. P is my initial value. R is my rate as a decimal, my interest rate. N is the number of times compounded in 1 year. And T is the time in years. So if you would like to go ahead and take a screenshot of this right now, I would certainly suggest that, as it will be very helpful for you as you're doing some of your homework a little bit later. So if Mike invests $3,000 at 7% interest compounded monthly, how much money will he have at the end of 4 years? So A is equal to 3,000, 1 plus 0.07 divided by 12 raised to the 12 times 4. So I'm cutting up this 7% interest rate 12 times throughout the course of the year. So every month, Mike will have a little bit more money in his bank account. And I'm doing that 12 times throughout the course of 1 year, and I'm doing that for 4 years here. So we can go ahead and evaluate this and figure out how much Mike will have at the end of 1 year. But let's keep going here. Let's say that Rachel has found a new and mysterious bank account that pays 100% interest. If Rachel invests $1 in the account to the nearest penny, how much money will she have if the interest is compounded? And here we have sort of a list: yearly, monthly, weekly, daily, hourly, and continuously. We're going to talk about continuously in a little bit. But noticing our trend that we went with before, it looks like this hourly, it looks like the more times that we compound our interest, the more money that it will yield us at the end of the year. So yearly just means once per year. Monthly is 12 times per year. Weekly is going to give me 52 times per year. Daily is going to give me 365 times per year. Hourly will give me even more than that. And continuously, we're talking about gaining interest in your account at every possible second that you could think of, or even that you could not think of. So Here, it looks like I went ahead and I plugged in. So here I have 1 for yearly and 1 for yearly because we're just talking about 1 year. Here I have 12 for monthly. Looks like it gives me a little bit more money, a little bit more money, a little bit more money, and a little bit more money. And when we talk about continuously, I'm continuously compounding interest. So I have infinities that I've placed in there. But we can't really work with the number infinity, right? We can't really work with a value for infinity. So what I went ahead and did is I graphed what this would look like. So I can see here that as n is getting closer and closer to infinity, that it ends up sort of leveling out here. So looking at this graph, it looks like it ends up leveling out. And it ends up leveling out to a value which we call E. And E is the value 2.71828, so on and so forth. It's an irrational value. And so E is the limit as n approaches infinity. And this limit sort of notation may be a little bit new for you, and that's okay. But I want to come back to this because this we do understand up here. This piece over here where I'm plugging in infinity and infinity. So that's what's happening in this graph. I'm taking 1 plus 1 over infinity, and I'm raising it to the infinity power, and we can see that here. And so it looks like my graph is just eventually going to level out and approach this 2 point something value, right? So here's my 2 on my y-axis. So as my numbers get really large, my graph is just going to approach this E value. So when we talk about compounding interest continuously, instead of plugging in infinity and infinity, we can actually use this E value. So this right here is my equation for interest that's compounded continuously. So compounded continuously. So let's do some examples here. So it looks like Jake the Snake checked online to see if there was a formula for compounding interest continuously, and quickly he found the above formula. So if we were having a face-to-face class right now, I would have us talk a little bit about this. But let's try some problems here. So what amount will Victor's account have after 3 years if he invests $5,000 at an annual rate of 8%? And let's just take a look here at, we'll set these up. So setting this up, I would have A is equal to 5,000, 1 plus 0.08, and we are compounded monthly, so 12, and for 3 years, so raised to the 12 times 3 power. Daily, I have A is equal to 5,000, 1 plus 0.08 divided by 365. We're doing that 365 times for 3 years. And compounded continuously, I have my A is equal to PERT, we call it the PERT formula. So A is equal to 5,000 E, and remember E is a number, and there's actually an E button on your calculator. Raised to my rate, which is not 80%, that would be quite the interest rate. 0.08 times my time, which is for 3 years. And you can go ahead and plug this into your calculator, and you can get a value for Victor's account after 3 years for each of these. And you should notice that my compounded continuously is the one that will yield the most money every single time. So you have some problems to try, so why don't you go ahead and check out that problem set, check out some of these problems, and please shoot me an email if you have any questions.